Cold Head Branch State Park lies in the northern physiographic section of Florida. The park contains 1,561 acres located to the east of State Road 21, just north of Keystone Heights. The park lies in the northeastern edge of the Central Ridge or Highlands. The northeastern boundary is formed by a relic marine terrace known as the Cody Scarp. Gold Head is situated between Trail Ridge, whose southern boundary lies about 8 miles to the north, and the Flora Home Valley to the south. The topography is typical of a karst landscape. The rolling hills are dotted with sinkhole lakes of varying ages and depths, and a clear spring that has cut a steep ravine as it flows into Lake Johnson.
The philosophy of the Park Service is to obtain original pieces of Florida. It's known as the original domain. It's not always prized pieces of property, but it's property that can usually be put back to the way it was before the white man entered Florida. When the Indians were here by themselves, they were considered actually a part of the ecology. When they burnt halfway across the state and the fire ripped through this area and on over to the coast, that was considered a natural system. When a lightning fire struck and caused a big fire, that was considered a natural system. The Park Service's philosophy is to maintain these natural systems, maintain the property as it would be maintained naturally. Sometimes that requires that absolutely nothing be done except protect an area. That can be seen in a ravine in the park. Other times it requires some actual physical management, and that's one of the reasons why we burn. Resource management is sometimes hit and miss. Back in the early 70s, it was thought that a winter burn in an area like this was considered proper. And every winter we go out with our torches and we burn different sections of the park. And as time went on, the Park Service zeroed in on a resource management philosophy, and it may not be quite right yet, but they're continually getting clues from nature and from stories, from descriptions from William Bartram and past explorers as to just how this area should be managed. We get clues from old photographs that say that this sandhill area was open. There was pine trees, there was wiregrass, and the turkey oaks weren't as thick as they are now. They were just shrubby-like. The fires kept them under control. After a period of time, they realized that winter burns exactly weren't what they were looking for. They realized with summer burns that most of the animals were adapted to a summer burning program, or spring, it's known as the lightning season program. During the months of May, June, and early July, that's when most of the fires were started naturally. The animals adapted to this, the plants are adapted to this, and the trees are adapted to this. The wiregrass, which grows and is the major fuel of the sandhill area, only puts up seed during the lightning season burn. So if we burn during the winter, we don't get this seed. That particular management practice was discovered by accident down at a Ranger Academy. They were doing a demonstration burn during the lightning season, which was considered the wrong time of year. And to their surprise, after the burn, the whole area came up and seeded. And they thought that up to that time, that wiregrass was a very poor seeder, that it didn't put out many seed, that the seed it put out wasn't viable. So it was by accident that they learned that management practice. They used to think that the burn period for the area was every 3 or 4 years. Now they're thinking that enough fuel develops in an area to burn every other year. And as a management practice continues on after several years, we find that the whole area begins to change.
This is an area where I assume we recently burned, and the burning seems to bring out the reseeding heads, the reproduction by seeds as opposed to vegetated reproduction of wild-grass. When was this area burned?
Last year we burned this area. It was an early spring burn about this time of the year. What it does, it brings out the seeds on the wiregrass. Wiregrass is a very tolerant plant, fire-tolerant plant, and what it does is once that fire hits it, it automatically sends a message to the plant to start to reproduce. The fire is usually, in this sandhill, is a cool type burn, and it really puts a lot of stress and strain on the plant itself.
Longleaf pine, the sandhill, classic sandhill, the co-dominants are longleaf pine and turkey oak, and the relationship has to do with fire versus logging. And I almost assume that at some time in the past this area may have been logged for longleaf pine, maybe even before the park bought it, because there aren't any really mature pine, just a very few mature pine. There are a lot of turkey oak. In this area, because there hasn't been much of a history of fire, the turkey oak are dominant, and there are just a few longleaf pines.
Also, the pines that we have here now, the pines that we're using now for seedlings, they have marks on them of cat faces from the old turpentine era, and when we burn, we have a problem of keeping them alive because of the sap that's oozing out of the cat faces. They catch fire, and we have to make sure that they're out so they won't burn up, and then we won't have any producing pines.
This is an area that you had indicated was a very successful burn in terms of regeneration of all the longleaf pine. What's the history of this area?
This particular area here is a successful area because of the fact that 5.5 years ago, the turkey oak dominated this area, and now the pines are starting to come in. And as you can see, the saplings are about 5 foot tall, which means that they're growing very rapidly right now. Probably the taproot has gotten down to where the moisture is.
The unique characteristic of longleaf pine, as far as this being what we call a fire subclimax, there are a number of fire subclimaxes among the North Florida, Central Florida type of communities. Longleaf pine is very, very unique in having the first 5 or 6 or so years it spends most of its energy sending down a taproot. And you can kind of tell the age of the tree because once it does that, then and only then does it start branching. And I see on a number of these trees now that the apical bud, which was originally dominant, and you just saw a straight shoot, and a lot of the smaller ones, there's just a straight shoot sticking up. This year I see, like on this one, I see 2 branches. On the other one farther over, I see 3 coming. And on the one beside you, there's another one with 3 coming. So this is the one where they start branching out, looking a little bit more like what you would consider older longleaf pine. So most of these in this area are probably 5 years old, and I see a lot of fairly small ones coming in, like over there. So it looks like, and the only thing I see through here in turkey oak are I guess we would call root sectors coming up.
Mm-hmm.
The mature trees, the turkey oaks have been killed. And what we're seeing is some of that brush coming up, which I'd assume another burn would probably wipe out.
The other plants here are very fire tolerant. The turkey oak seems to be somewhat semi-fire tolerant. If you catch them in an early spring burn, it really does a job on the root system also.
We are now walking through fairly typical type of scrub community, Florida scrub or big scrub community that is characteristic of North Florida and some of Central Florida, where this kind of an area is dominated really by a very, very poor soil in terms of nutrients, very, very well-drained soil, and this white, what we call well-sorted marine deposited soil, which is almost not zero nutrients, but extremely low in terms of nutrients. And most of the vegetation is what we call evergreen scrub, dominated by various types of oaks. What I'm looking at like right now sort of looks like the dominant, right through here, the dominant tree, or it's really a shrub. It's not a tree. In this area is sand live oak that has a very characteristic boat-shaped leaves. And I noticed what's Chapman oak that's just now coming out again. These are really very fire tolerant because even when a brush fire comes through, they reproduce from the root system. Now, the rosemary, that's a very good example of rosemary, but where fire reoccurs, it tends to wipe it out. I don't know how frequently. This doesn't look like this has been fired or burned very much, has it?
We keep this area here free of fire because of the fact that we're talking about the rosemary. The rosemary is not a very good fire-tolerant plant. In fact, when we burn in the sandhill, where sometimes the rosemary does occur, it literally wipes them out.
Mm-hmm.
And the scrub area is a place where the rosemary does occur, and for that reason, we try to keep the fire away from this one particular area here.
I notice there's a lot of snowball lichen, we call it snowball lichen, and red soldier lichen as ground cover there, as opposed to the sandhill community. There's essentially no wiregrass through here at all, almost no grasses at all. There are some little needle palms and little needle palmettos, but everything under there is either shrub, or it's lichen, and of course there's a fairly heavy leaf litter.
That probably comes from the economy of the soil. This soil here is very porous, very poor in minerals. The water does not stay on this soil at all. It goes right down to the bottom.
Mm-hmm.
And the wiregrass just doesn't seem to flourish very well here.
What kind of animals do you normally find in here?
The one main animal or bird is the scrub jay, which is kind of hideous. And you got some rats that hang out here, and different snakes. You might find occasionally a rattlesnake or a black racer.
Mm-hmm. Well, that scrub jay is, I don't know whether it's an endangered species, but this is, I think, the farthest north that it occurs in Florida, the Florida scrub jay. And it's in the scrub zones that are protected here on the park. I assume that's part of maybe why they're not burning this area, too, in terms of management.
Very much.
What about gopher tortoise? Do you see those here at all?
Gopher tortoise seem to go for mostly sandhill. I don't know any particular reason. Probably because of the soil itself. Once you get past this sandy, dry soil on top here, there's a hard pan underneath, real hard, black hard pan, and it would probably be a little bit tough for the gopher tortoise to dig into.
This area of sand pine scrub is certainly much different than the scrub, the more typical scrub that we see in North Florida that we just saw in the other part of the park. It looks like there's tremendous reproduction of sand pine, and also relatively, although these aren't totally mature, but there's a tremendous amount of reproduction, a lot of young pine seedlings, and yet this area, looking at the soil and all, with the yellow sand being on top, looks to me like it should be a sand hill. What's the history of burning, and is there any idea of why there is a sand pine scrub here in this part of North Florida?
This is really strange to us too, also, because as far as the last 6 years here, there hadn't been any fire through here at all. We haven't burned it, or has there ever been any natural fires through here. That's the strange thing about this one particular community here. Sand pines usually like to reproduce by opening their seeds during the burn. Since there's been absence of burns here, it's really strange that they're actually flourishing in this part of the park.
We're standing now in what we would call a xeric hammock, which is a climax community for the other types of communities that we've been looking at in this park, the sandhill and the scrub community. The soil is almost identical to the sandhill. It may be, in terms of the soil analysis, the students have found that it has a slightly greater amount of humus, a slightly greater amount of organic material, but relatively it's a sandhill type of soil. The kinds of community, the kinds of plants that we see here, I notice still probably a lot of this tree here is a longleaf pine, but there are no longleaf pines in the understory. There are no seedling longleaf pines, 1, 2, 3-year-old. The quadrats that our students have done, if you do a clutter, for example, in this area, there aren't any pine seedlings of any type. There are oak seedlings all over. There are a lot of mature, or at least reaching maturity of the laurel oak, the sweet gum that we were looking at. There was some sweet gum ahead of us that are fairly large trees. They're actually getting up almost as tall as a longleaf pine. And there are large blue jack oak. So largely we're looking at, I guess, what, live oak, sand live oak, blue jack oak, again another oak. And then the exceptions would be sweet gum, and I noticed a dogwood tree, which of course is always an understory. And we've been talking all the way through in terms of the other communities, the history of fire, and the history of burn versus unburn. What's the role of fire in this kind of a community as far as the history of it?
This particular community here is a classic example of the absence of fire throughout the year. This one particular area here has not been burned, probably since the control burn was set into effect about 10 years ago. This is the reason why you have these type of plants here, the laurel oak and the live oak. They've climaxed out because of the absence of fire.
They've almost completely shaded out the longleaf pine, because basically the pine trees, longleaf and sandpine, are shade intolerant. So with this kind of a canopy where, because we're out in somewhat of an open area, but we're actually going up into a very classic type of hammock situation where the ground is almost completely shaded as opposed to the areas we've been looking at. So there is a great difference in terms of ground cover as well as in terms of the dominant trees. This area is in a location that geologically is described as karst topography, and karst really refers to having a limestone bedrock, which is certainly in the case of Florida, and this area of Florida is probably around 95% soluble. In other words, as much as 95% of the actual bedrock could dissolve. So in that kind of a system, you have a lot of sinkholes, a lot of essentially dead streams that come out of the sides at different aquifer levels, or the sides of hills or slopes or ravines, and then will empty into a lake that has no outlets. The lake that we're talking about, Deer Lake, is probably a very, very classic type of sinkhole lake with a very steep drop-off, steep slopes, down to almost no littoral zone. This area, is there any idea of the depth or how old the lake is?
I'm looking at the sides of the hill, and since this one here drops off very abruptly, it's probably a younger lake. Depth-wise, there's been tales of it being 50 to 60 foot deep.
Well, let's go down and take a look at the lake closer.
Sure.
One guy. All right, I know this area we were talking about, the littoral zone, and the littoral zone is generally defined as the depth at which you get enough light penetration to support plants growing on the bottom. One of the things I noticed is most of these plants right here that are underwater should not be underwater, so that must mean this water level is up somewhat from what it would normally be. Is that correct?
Very much so. We had some rainfall a couple of weeks back that really brought the level of the lakes and throughout the park up. This one here is up probably about 2 to 3 feet.
That would get it beyond this. Most of this is sedge and things like this, and there's even a little shrub right there, a tree. And I noticed, except for that, which is really sort of like an ecotone, there aren't that many plants on the bottom, because I think I'm seeing, certainly out there, it looks like it's very clear, and I'm seeing the sand that's actually right down there on the bottom. So it's almost a direct drop-off, probably within about, 4 or 5 feet ashore. I imagine it drops off very distinctly.
That's true. Before the rainfall, the water was about right there at the edge there, and it went straight down. You could see the sand and a few little sunfish that would come up to feed on. And then the rainfall brought the water up to where you see it now.
Students have been looking at the lake in terms of dissolved oxygen and nutrients, and it has very high dissolved oxygen, which I think you'd probably expect, because there's really nothing in there much to pull it down. Nutrient levels are fairly low. What kind of fish would you find or have been identified from this lake? Has there been much done with the lake?
Probably the dominant fish that's in this particular lake here is sunfish. There are some gambusi minnows, which the sunfish feeds on, and probably bass would be the next in line. Catfish, maybe, because the lake is so clear and there's not much of the type of food that catfish like to feed on. You probably wouldn't find any of those around.
I noticed a little blue darner sitting there, probably just freshly emerged this spring. That's something that I think would probably be associated. The larval stage, the nymph stage, actually is aquatic and feeds on the vegetation along the bottom. In order for them to change, metamorphose into the adult stage, they have to climb up on some kind of emerging plant or stick or something and molt, split that old coat. Sheila Lake is considered to be probably one of the oldest lakes, I think, in North Florida, North or Central Florida. I know that I've read some papers where they pollen dated this lake to over 30,000 years of age. And I noticed one of the things we need to do, like, we were looking at Deer Lake, and Deer Lake is certainly a much younger lake geologically than Sheila. Sheila Lake has sort of a broad area where there's been erosion all the way around the lake. There's a marshy area here that we're standing in which doesn't even exist in Deer Lake. And we've got the St. John's wort, very similar to what we saw, what we see in basin marshes. And I noticed, for example, there's a red maple seedling that's starting to come up here that's probably been, I guess, carried in by birds or something. And there's a lot of broom sedge, andropogon around here, which again is indicative of a marshy situation of a lake that is in a progressive state of evolution as opposed to something like Deer Lake. Do you know much about the depth of the lake?
This lake here has been measured at about 60 foot. The divers that go in here have measured about being about 60 foot, so it's a good, deep, clean lake. As you said, the slopes of the lake tend to tell you that the lake is possibly a little bit older than Deer Lake.
Yeah, there is a littoral zone. You can see a littoral shelf which probably extends out about, well, I don't know, 10 feet or 12, 15 feet, which doesn't even, by the time you're out that, I think that deep in Deer Lake, you'd probably be 20 feet deep or more. This lake is an example of a lake that is in a karst topography, that instead of the very steep-sided sinkhole-type lakes that we were looking at with Sheila and Deer Lake, we're looking at a solution basin lake. This is a very broad system that I would have seen by looking at the tree line. At one time, this whole area, this whole valley probably had water in it, and the lake was all the way up to the tree line. We're standing now in what was probably not too long ago a marsh area. We have the same kind of broom sedge that we have in a basin marsh type system. We also have a lot of wax myrtle coming in here all over the place. There are seedlings in every stage of development. And then as you look out, this is a type of a lake system where there's a lot of floating vegetation. We have different types of vegetation that we classify the littoral zone. We talk about emergent vegetation in terms of the types of the leaves with arrowhead and with the button sedge and things like this. And then the floating vegetation with the yellow and the white water lilies, which we have here. And it's fairly extensive, the water lilies, and then there are different types of grasses that really are in stages that tell you this is shallowing up rather than that this is getting deeper. What's the depth? Because we talked about the depths with Sheila and we talked about the depths with Deer Lake. What kind of depths are we looking at with Lake Johnson?
Lake Johnson is probably one of the older lakes around in this area. Because it's being old, rainfall has washed a lot of material into the lake, really shallowed the lake down. As opposed to Deer Lake, this is a very shallow lake. In fact, it's only about waist deep out in the lake. This particular part right here was underwater back in 1973. We have pictures of some of the rangers putting down signs where the motorboats couldn't come from this side of the lake over to the other side of the lake. So the last documented time this was underwater was back in 1973.
This is a good example of what we call a transition zone from a lake edge, from the littoral zone, through a marsh up into essentially a shrubby border zone, because we got, like we were talking about wax myrtle, but there were also willow. And that is both of those are good indicator plants of transition zones. So the lake system, This is a very different type of lake, even though we're still talking about the same kind of topography, same park system, but it's very different in terms of history, in terms of its hydrological characteristics. This is an area, after we just finished looking at the lake, that is a natural succession, and what we call hydraulic succession. And the area that we're in is a relatively good example of hydraulic succession with the Spartina. This is Spartina bakeri, which is the freshwater equivalent of the salt marsh Spartina that we have all along the salt marshes in North Florida. And we have around us a lot of maiden cane. There's a lot of vegetative growth where the soil isn't uncovered anywhere here. This is just totally covered, so this is sort of a later stage in terms of marsh succession. What sort of animals do you normally find in this kind of a system, Nathan?
Normally in this area here, we would find probably the most dominant animal would be the marsh hawk. He comes in frequently. He's also a carnivorous animal. Also rats here, snakes such as the cottonmouth moccasin. They prey on the rats by laying in the paths where the rats would go and come. And also there's a type of a bird, a wren, that makes their nest in the Spartina grass.
One of the other woody plants that I see in this area is the buttonbush over there. Of course, it's not leafed out yet, but where do you usually find that in this kind of an area?
Buttonbush is very at home in this type of area, mostly closer down toward the lake. That would give you the impression that the lake was probably up here not too long ago because of the buttonbush being this far away from the water. Normally they're down right on the water. Right now we're about maybe 100 yards or so from the lake, and that's a fairly good distance from the lake for a buttonbush to be just out in the open.
Well, I know in a typical swamp situation like the Okefenokee or some of the other swamps that we have around here, cypress swamps, you see buttonbush right down there in standing water. So it's not that it's, you know, atypical, but it's very typical for it to be in standing water, periodically flooded water.
This here is a lot of humus or grass and leaves that has compiled throughout the years of the lake, moving in and out, bringing in new stuff. As you said, it's high organic. That's what we call lake muck.
I noticed when we uncovered all of this dead material, the leaf litter, I noticed seeing the sprouts, the new sprouts of the sedges and probably some of the other types of grasses here coming in that right now when you just look down on top of it you can't see it. I even see over there some little seedling Spartina coming in that are just cropping up here after the winter, so it's an interesting system. It probably pretty well protects it from cold.
Very much so. Also this is where our burn control plays into effect. When you come in and burn off the old grass, it gives the new shoots some area or a way to get to the sunlight to grow. If this litter was just left on the ground to rot and turn into humus as we got here, throughout the years it would smother the roots out.
I notice one of the good things about either natural burn or prescribed burn is that all of this, when it gets burned, becomes part of the nutrient cycle and is added to the nutrients in the soil. So it's not something that when you burn the area, the nutrients are lost to the soil. It's added in the form of carbon. So it looks, compared to the other types of soil, this is certainly the only black soil that we see on the park.